The planet Earth is estimated to be 4.5 billion years old and is the only life-supporting planet in our solar system. To understand the geological history of the Earth, scientists have scoured the Earth searching for the oldest rock to be radiometrically dated. In northwestern Canada, scientists discovered rock about 4.03 billion years old. Then in Australia, scientists had discovered minerals about 4.3 billion years old. Since it is thought that the bodies in the solar system may have formed at the same times, scientists analyzed the rocks of the moon collected during the moon landing, and even meteorites that have crash-landed on Earth. Both of these materials date between 4.4 and 4.5 billion years. By this finding, it is clear that elements and minerals are important components of the planet Earth. Let us further examine the elements and minerals that forms the rocks. The planet Earth is composed of various kinds of elements. There are about 100 natural chemical elements found in Earth crust, mantle, and core, occasionally as discrete elements. These elements are in solid form in the outer layer of the Earth and in hot and molten form in the interior. The most abundant elements in the Earth crust are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. These 8 elements made up 99% of the elements found in the Earth crust. Other elements like titanium, hydrogen, phosphorus, manganese, sulfur, carbon, nickel, etc. are also found in Earth crust. These elements exist in a variety of rocks and are formed through physical and chemical processes, both endogenous and exogenous. Let's see how these elements form minerals. For example, oxygen, the most abundant elements, readily combine with many of these elements in the form of oxide. Iron oxide, aluminum oxide, silicon dioxide, etc. Likewise, elements combine with each other to form compounds. These naturally formed compounds and elements of Earth are called minerals. Minerals are therefore inorganic solid substances that are present in nature and can be made of one element or more elements combined together. Remember that only about 1/4 of the elements are involved in the formation of minerals to any significant magnitude. There are almost 5,000 minerals identified, with new types identified almost every year. However, majority of rocks are formed from combination of few common minerals, referred as rock-forming minerals. The rock-forming minerals can be grouped into 7 principal categories or families based on their chemical properties and internal structure. The 7 principal rock-forming mineral groups are namely silicates, oxide, sulfide, sulfate, carbonate, halide, and negative elements. Let us examine these rock-forming mineral groups one after another. Silicates. The largest and the most important mineral family consists of silicates. The majority of the rocks of the Earth crust are composed of silicate minerals, which combines the 2 most abundant chemical elements in the lithosphere. They are oxygen and silicon. Silicates minerals have 2 major subcategories, namely ferromagnesian silicates, sometimes called dark silicates, and non-ferromagnesian silicates, sometimes called light silicates. These 2 subcategories are distinguished from one another by the presence or absence of iron and magnesium in their composition. Feldspar and quartz are the most abundant of silicates minerals. Quartz itself is composed of pure silica. Mineral groups of ferromagnesians are namely olivine, ferroxenes, amphiboles, and biotite mica. Olivine consists of magnesium, iron, and silica. It is usually a greenish crystal, often found in basaltic rocks. Ferroxenes are a group of dark-colored rock-forming minerals found in igneous and metamorphic rocks. They are formed under conditions of high temperature and pressure. Calcium, aluminum, magnesium, iron, and silica are major elements of peroxide. Amphiboles consist of calcium, silica, iron, and magnesium. It is in green or black in color and are found in igneous and metamorphic rock. Biotite micas comprises of potassium, aluminum, magnesium, iron, silica, etc. It is commonly found in igneous and metamorphic rock. It is black or brown in color. Non-ferromagnesian minerals are namely muscovite mica, potassium feldspar, plagioclase feldspar, and quartz. Muscovite is the most common minerals of mica family and is present in igneous, metamorphic, and sedimentary rocks. It is colorless or brown in color. Potassium feldspar is an important tectosilicate mineral that forms igneous rock. It is white to gray or pink in color. Plagioclase feldspar are important minerals in most igneous rock. It is white to gray in color and striations often appear along cleavage planes. The next major rock-forming mineral groups are oxide. An oxide is an element combined with oxygen. Only a relatively few elements are able to do so. The most widespread of oxide are those that combine with iron, particularly hematite, magnetite, and limonite, all three of which are major sources of iron ore as well as being a common rock-forming minerals. Corundum is an aluminum oxide and is found in igneous, metamorphic, and sedimentary rocks. Although quartz has the chemical composition of an oxide, it is classified as silicate mineral because of its internal structure. The next rock-forming mineral groups are sulfide. The sulfides are composed of sulfur in some combination with one or more other elements. Pyrite, for example, is a combination of iron and sulfur. Many important mineral groups such as galena and chalcopyrite are sulfides. These groups are commonly found in many types of rocks. The next rock-forming mineral groups are sulfate. The sulfate group includes minerals such as gypsum that contain sulfur and oxygen in combination with some other elements. Calcium is the principal combining elements in sulfate groups. The sulfate group's minerals are usually light color and are mostly found in sedimentary rocks. The next major rock-forming mineral groups are carbonates. Carbonates are also light color or colorless minerals that are common constituent of sedimentary rocks such as limestone, largely made from calcium carbonate in its mineral form of calcite. Carbonates in general are composed of one or more elements in combination with carbon and oxygen. The next major rock-forming groups are halides. The halides group is the least widespread of any. The word halide is derived from the word meaning salt. The halide minerals are notably salty, such as halite or common table salt and fluoride. The next rock-forming mineral groups are negative elements. A few mineral groups may occur as discrete elements, which means they don't combine chemically with other elements in nature. These are referred as negative elements, for example, precious metals such as gold and silver. So the presence of minerals in rocks provide valuable insight into the geological history of a rock, and it is often used to ascertain the age of a rock. Next time when you see a rock, remember that it is made up of various elements and minerals.